Hey, welcome to The Explainer. Today, we're going to get into a really fascinating new method from Meta AI. It's called ASTRO, and it's all about teaching artificial intelligence a skill that, is second nature to us humans, the ability to think twice.
We all know today's top AI models are incredibly powerful, right? But have you ever stopped to think about what happens when one of them gets something wrong, especially when it's tackling a really, really complex problem? Well, it's not just that they spit out the wrong answer. See, the way these AIs think is kind of like a one-way street. One tiny misstep right at the beginning can send it down a completely wrong path. And it'll just keep going, building this super elaborate, confident-sounding argument, all on a totally faulty foundation. And there's just no turning back. All right, so here's the plan for this explainer. First up, we'll look at this big reasoning roadblock AIs currently face. Then, we'll get into how we can actually teach an AI to think twice. After that, we'll break down the ASTR's training method itself, check out the pretty amazing results, and finally, we'll talk about what this could mean for the future of AI. Okay, section 1. AI's reasoning roadblock. So what's the core problem here? What are we really trying to fix? So, as powerful as they are, large language models, or LLMs, are fundamentally autoregressive. Now, that's just a fancy way of saying they generate their response one piece at a time in a single irreversible line. Just imagine trying to write a long essay, but you can't use the backspace key at all. Whatever you type, it's there to stay.
And this is the perfect example of the problem. So, in the research paper, they gave a model a math problem about some clay in a box. It made a little mistake early on in its calculations, but just confidently marched forward. It ended up concluding the final answer is 480 grams. The correct answer? It was 240.
So yeah, this straight line thinking, it's a huge roadblock. I mean, if we're ever going to trust an AI with really important stuff like scientific research or medical diagnostics, it can't be allowed to just blindly double down on its own mistakes. It needs a way to stop and fix them. So that leads us right into section 2, teaching AI to think twice. And this is exactly where Meta's new ASTRO framework steps onto the scene as a really interesting solution to this whole reasoning problem. ASTRO stands for Autoregressive Search-Taught Reasoner. To put it simply, it's basically a training program to give a model something like an inner monologue. It teaches the AI to explore different ways to solve a problem, to reflect on what it's doing, and, this is the most important part, to backtrack if it realizes it's gone down a wrong path. Here's the difference in a nutshell. A standard LLM is driving down that one-way street. Once it makes a turn, that's it. It's committed. But an ASTRO-trained model, it's more like it's in a car with a GPS and a reverse gear. It can pause, realize it took a wrong turn, and actually backtrack to a previous step where everything was still correct before trying a new path. And get this, it's not just a metaphor. The model is literally taught to write out phrases just like this one. It learns how to interrupt its own process with self-doubt. I mean, for an AI to actually type out, our solution may not be correct so far, let's go back. That is a total game changer in how these things behave. So how on earth do you teach an AI to do that? Well, that brings us to section 3 and the ASTRO training method. Think of it like a 3-stage recipe for building a better reasoner. The process breaks down into 3 main stages. First, they generate a huge amount of data showing all sorts of reasoning paths. Second, they use that data for what's called supervised fine-tuning. And finally, they polish the model's new skills using reinforcement learning. Okay, so step 1 is all about getting the right study materials. The researchers used this incredibly powerful algorithm called Monte Carlo tree search. You might have heard of it. It's famous for mastering games like Go. And they used it to explore thousands and thousands of possible ways to solve complex math problems. It mapped out everything: the right paths, the wrong paths, the dead ends, the whole shebang. In step 2, all those explorations get turned into over 36,000 study notes for the AI. But here's the brilliant part. These aren't just a bunch of perfect A+ answers. They're filled with the messy, realistic process, the dead ends, the commands to backtrack, the moments of self-reflection. So the AI isn't just learning the right path, it's learning from all the wrong turns too. It sees the whole journey. And finally, in step 3, they use reinforcement learning to reward the model. But, and this is super important, it doesn't just get a reward for spitting out the right answer at the end. It gets rewarded for how it got there, for using that whole reflection and backtracking process to find the solution. It's being encouraged to show its work and think more carefully.
Okay, that all sounds fantastic in theory, right? But did it actually work? Let's move on to section 4 and take a look at the results, because they are pretty impressive.
Okay, take a look at this. On a standard benchmark called Math 500, the base Llama 3.1 model scored about 66% correct. But after the ASTRO training, its performance jumped to nearly 82%. That's a 16-point absolute gain. And in this world, a 16-point jump is absolutely huge. The improvement was even more incredible on the American Mathematics Competition, or AMC, benchmark. And these aren't your average math problems. The AMC is known for being incredibly tough. Here, the ASTRO-trained model saw a nearly 27-point absolute improvement. That's just wild. And it shows this technique really shines on the hardest problems. And you see this pattern everywhere. Across multiple super difficult math benchmarks, the ASTRO model just blows the base model out of the water. I mean, just look at the AMY results. That's an elite math competition. The performance tripled from 10% all the way to 30%. That's just incredible. But this might be the most crucial takeaway of all. The researchers found a really strong positive correlation between how well the model did and how often it used that backtracking skill. In other words, this wasn't some random fluke. The model got better because it was backtracking. The more it learned to rethink, the higher its score went. Simple as that.
Okay, so all of this brings us to our final section, a new path for AI. Because this is about way more than just getting better scores on a math test. What's so cool about this is that it gives us a window into the AI's mind. We can actually follow its train of thought. We can see it start down one path, pause and realize it made a mistake, backtrack to a point where things were still correct, and then try a whole new approach until it lands on the right answer. This kind of structured, traceable reasoning is a huge deal for building AI systems that we can actually trust. And that leaves us with this huge, final question. The ideas behind ASTRO aren't just for math problems. Imagine applying this kind of self-correcting logic to things like scientific discovery, or complex code generation, or even legal analysis. I mean, if we can teach an AI to correct its own reasoning, what's next? What kind of problems, once totally out of reach, could we now solve?